Assalamu alaikum, dear friends. Today we will discuss about the topic is our mathematical inductions. We also know that mathematical induction is conceived three types of the steps. Number one, first step is n equal to 1. Number two, n equal to k. And number three step is n equal to k plus 1. Here, this is a question is regarding about 9231 and from 2015. This is our question, and we want to prove this question by using mathematical inductions. For that purpose, first of all, we will apply our first condition n equal to 1. When we put here n equal to 1, we take its left hand side. What's our left hand side? We replace x as a 1, x e power ax. Here we take its first derivative. We know that this is our product rule of derivations. X e power ax and take its derivative is a. Now plus e power ax and x derivative is 1. We have x e power ax into a plus e power ax. Now we take its right hand side. In right hand side we put 1. This is our right side. A 1 minus 1 e power ax plus a n and x e power ax. Here we put n instead of, we put here 1 instead of a. Okay. Now next step is a power 0 e power ax plus a power 1 x e power ax. We can represent it by x, other is small x. I think it's correct one. Now this our side is e power ax and ax e power ax. Left hand side and right hand side are equal, so our first condition is proved. Our first condition we have proof. We say that true for n equal to 1. Now we have to apply our second condition. Second condition we say that's n equal to k. Now in above question we say that this is our above situation, this is our above conditions. In this condition we put here, we will replace n with by the help of x. This is our k, this is our xk, and here x e power ax equal to k and a k minus 1 e power ax plus a k x e power ax. This is our, I will write it clearly. Okay. Now we will go forward. After that, this step we say that it's we assume. We also say that we assume. Okay. Now here we will apply n equal to k plus 1. This is our third condition. We have to k plus 1 dx, k plus 1 x e power ax. Here we going forward. Now, could we write it into this one? D over dx, and d over dxk. This is also k. How? This means that if these are multiplied, this we get this result. Okay, we can write it into this form, and we just simplify. We have to know about the indices rules. Okay, now again d over dx. What is the equation of this equation come from here? Okay, we put this equation from here. K e a k minus 1 e power ax plus ak x e power ax. Now, further, we have to apply the derivative from this rule k a k minus 1 e power ax. The answer is a. Now, next step is over ak and we get x e power ax. Now, is we will simplify by using product rule e power ax into a plus e power ax, x derivative will be 1. We write it only 1. After that, we will going toward now we have to write it k a power k minus 1 e power ax. This a and this will be take its power. We have to write it ak a, we write it here plus ak x e power ax into a. Now we go to the next step plus ak e power ax, this one. After doing this one, we have to sign a k minus 1 and plus 1 because these k will be add in this term. E power ax plus a k ak plus 1 x e power ax plus ak e power ax. Okay, anything is common here. This will be cancelled by this one k ak e power ax. Now we write it ak e power ax plus ak plus 1 x e power ax. After that, doing this one, we have to know about all solutions and anything common. We have to find this one. Here AK is common, right? AK term is common. Also, no, any and E power AX. This is also common. E power AX and remaining term is K plus 1. Ah, yes. Yes, it's correct. AK plus 1 and X E power AX. So we have to require over these answers because we if we go to the forward here, uh, actually our need is about this one. We put n. We have to know about k plus 1 a power k minus 1 and plus 1 e power ax plus a k plus 1 x e power x. This is all required. Okay, if this is our right hand side, we have our right hand side proved. Proved. This is our required answers. Thank you so much. We will again discuss about more topics of your kind syllabus. Thanks so much.